When a global organization relies on aging infrastructure to process thousands of international business applications, the operational reality looks like this. Fragmented workflows and disconnected databases force administrative teams to manage compliance through manual data entry. This manual dependency creates severe bottlenecks, directly slowing down the speed at which corporate supply chains can operate. WEConnect International recognized that to accurately verify and onboard women-owned business enterprises across the globe, they needed to entirely reconstruct their digital ecosystem. The engineering challenge is complex. The system must operate as a highly regulated compliance engine, while simultaneously serving as a frictionless marketplace for buyers and suppliers. Moving to a unified cloud-native architecture allows the organization to centralize data that is currently siloed across regional forms and disparate legacy records. This isometric model maps the solution's 7-layer architecture, building from scalable infrastructure through secure data management to the user experience. The API layer manages bidirectional exchange, translating front-end actions into secure back-end logic. Its utility is ultimately determined by the top user experience layer. To understand how this enterprise architecture actually functions, we have to reverse engineer the interface of its 3 distinct user journeys. The first critical perspective belongs to the applicant, the business owner attempting to enter the certification ecosystem. This dashboard serves as the primary user interface. It is specifically designed to organize and structure initial compliance data before it reaches a database. Historically, incomplete submissions and missing documentation have delayed certification life cycles by weeks. To eliminate those delays, the system utilizes dynamic, role-based onboarding paths. The interface adapts to the user, requesting only the specific documentation required for their business category and region. We can trace exactly what happens when a user submits that data. Clicking Upload Document initiates a sequence that plunges straight into the architecture. The front end immediately hands the secure data packet off to the modular API gateway framework. Here, the backend evaluates the user's regional preferences, normalizing the incoming data so it fits a global standard. The document then reaches its resting state inside the secure data management layer, fully encrypted and logged for audit. Because the front end is decoupled from these heavy backend processes, the system only needs to serve lightweight interface components to the user. This allows business owners in regions with unstable, low-bandwidth connectivity to maintain a reliable connection to the platform. Establishing strict data normalization at the point of entry provides the prerequisite for accurate downstream automation. Once data is secured, the perspective shifts to internal system administrators responsible for verifying compliance. This is the Certification Review Workspace. It synthesizes complex application data and regional tax documents into actionable intelligence for the reviewer. Introducing automation into highly regulated compliance workflows introduces the risk of algorithmic error, where software might overlook nuances a human expert would catch instantly. To mitigate this, the architecture enforces a strict boundary. It uses AI exclusively for decision support, never for final decision-making. When an uploaded document hits the AI orchestration layer, the model parses the text and evaluates it against current compliance rules. The system scans the document for eligibility metrics, tagging missing signatures or potential anomalies with a visible warning flag. Crucially, the system generates an explainability record. Every AI recommendation maintains a clear, auditable trail detailing exactly why an anomaly was flagged. The final compliance workflow is governed by role-based access control. The system halts the process at a locked gateway. A certification status change can only be executed when a human administrator approves or overrides the AI recommendation at that gate. Architecting responsible AI involves building transparent auditability to empower human expertise, rather than replacing it. That verified compliance data is then passed to the final system participant, corporate procurement teams searching for diverse suppliers. A static registry lacks the connectivity to drive marketplace volume. Generating liquidity requires a logic layer that actively surfaces suppliers to corporate demand. This buyer-supplier discovery interface is built to surface complex, multivariable marketplace matches. Corporate buyers require highly granular variables, filtering for precise manufacturing capabilities, regional distribution, and specific diversity metrics. When a buyer executes a specific search query for a supplier in a niche sector, the architecture must translate procurement intent into results. The back-end matching layer receives the query, parsing the user's parameters into distinct metric lines. Those lines feed into a semantic matching engine. Instead of relying on keyword hits, it evaluates the broader context and intent of the procurement requirement. The engine cross-references the search criteria against the live relational database, pulling compliance records of matching supplier nodes. It performs a real-time calculation, assigning a compatibility percentage score to each verified supplier and ranking final results for the buyer. Pairing human-governed compliance with semantic discovery allows corporate buyers to use verified data as a filter for strategic procurement. If we pull back from those individual user journeys, we can evaluate the protective infrastructure holding the ecosystem together. Processing sensitive corporate data at a global scale requires non-negotiable DevSecOps controls, including end-to-end encryption and multi-factor authentication. The primary operational risk in global digital transformation centers on the potential disruption of active certification activity during the deployment window. Abruptly halting a legacy application to activate a new system introduces unacceptable risk. If data fails to map correctly, global operations freeze. To prevent downtime, the deployment utilizes a strategy known as parallel validation. This timeline illustrates the transition. Over a defined period, legacy application data is continuously synchronized into the new platform models, keeping both systems populated. During this phase, both systems process the exact same workflows concurrently. Administrators compare the outputs to identify and resolve any mapping discrepancies. Only after successful parallel processing does the team execute the final, controlled cutover to the new platform. This architectural blueprint establishes WEConnect's operational independence while surfacing verified suppliers to a global network of corporate buyers. By engineering a foundation of auditable trust, the platform provides a scalable infrastructure where supplier discovery and global compliance function in tandem.